This video is the conclusion for Chapter 3, Section 1. Looking here at Table 3.1, it is a summary of measures of central tendency. So this is a great time to go back and look at whatever document you've been writing on, whether it was index cards, an electronic document, wherever you're taking really good notes on these words. And this is going to boil it down. And you might want to add these words like to your index card. You want to make sure you've got the symbols. But this whole section we've been talking about mean, median, mode, and mid-range. Researchers and statisticians must know which measure of central tendency is being used and when to use each measure of central tendency. So this whole section 3.1 is about measures of central tendency, trying to find the middle, trying to find the center, trying to find an average, if you will. These properties and uses, the properties and uses of the four measures of central tendency are summarized next. And so you might want to underline, highlight, think on, look at what all is going on down here, like on the mean. And I underline some words like all, variance, cannot, not necessarily only one, open-ended, called outliers. So just some things to kind of soak on and think about for mean. Some other things to think on: median, that middle, it's the center. There's a lower half and upper half. The mode, most typical, the easiest one, but you need to use these that we talked about, the nominal, the categorical. At the top of the next page, it keeps going to say the mode is not always unique, and we know that because we could have more than one. It could be bimodal, and it may not even exist. As that gets clear, I hope. And then maybe it'll get clear this time. Okay. And then it talks a little bit about the mid-range. It's easy. And then there's a little bit more. Distribution shapes. Frequency distributions can assume many shapes, but the three most important. And I don't know that you want to write these down. You may already have these memorized. They may make sense to you. But there are three that you need to have in your working vocabulary: positively skewed, symmetric, and negatively skewed. So let's talk about each three. In the positively or right skewed distribution, and I have to go ahead, I've got myself a note about page 64. So let's go ahead and look back over here at page 64. Whenever we were on 64, we had the bell-shaped, J-shaped, the reversed, but we had right skewed and left skewed. So we've already looked at this bell, right and left. So looking here, it just says a little bit more. And so what it's saying is the majority of the values are going to fall to the left of the mean, keeps on going, cluster, distribution, a tail to the right. So positively and right skewed. Right-tailed, I got to get those in my brain. So positively skewed and right-tailed. So right here, it is the tail is pointing to the positive direction on X, and it's pointing to the right. So whatever you need to remember, that this is positive, this is right-tailed skewed, this is what it looks like. But then there's these three little words in here. And so the biggest thing I'll say is let's look at an overview of these three drawings, or graphs. Notice that in all three of them, the median is in the middle. Well, that makes sense, right? Median is going to be in the middle. But then, after I think in my brain that median is in the middle, I'm like, which next one would be easier for me to recognize? And it's, for me, mode. It's going to be the tallest one. So if your drawing is going like this, the median's here, but the mode's got to be taller, and then it goes off into that tail. So the mode's going to be on the left of it, and then the mean is at the other place. That's how I remember. Let's see if it holds true to this left-tailed skew. The left tail, or the one pointing to the negative, median's in the middle, and look, mode again is the tallest, but it's on the right side now. So on the left-tailed skew, it's on the right side, and then mean is in the other spot. But the cool thing, when we talk in just a minute about the symmetric distribution and normal curve, the mean, median, and mode are going to be stacked. They're going to be all in the same spot. So an example it gave for this is like grades. Like if on the first test, in this other statistics class, not ours, the students didn't do very well, the grades were bunched down here with maybe C's, D's, and F's. And there were just very few A's and B's. Well, that's not going to be our class. Our class is going to be this other one. It's going to be the left-tailed skew, where we're going to have most of our grades on the first test, like up here on A's, B's, C's, and very few D's and F's. It gives us a little bit more description about the left tail and the right tail, and it mentions tests and symmetric. And symmetric is just evenly distributed on both sides. It mentions IQ scores. If you've ever had any dealings with IQ tests, they have the middle and then they branch off into the other sides. It does mention a little bit more on the next page about this left tail skew. And I'm at the top of the next page, and it is saying when the majority of the values fall to the right of the mean. And it talks about the cluster, and it's talking about where the mean and the median and mode fall. But again, I just like to think median's going to be in the middle, mode's going to be the tallest one, and mean's going to be on the other side from median from the mode. And it gives negatively skewed, like if everybody scored well on the instructor's examination. When a distribution is extremely skewed, the value of the mean will be pulled toward the tail, but the majority of the data values would be greater than the mean or less than the mean, depending on which way the data are skewed. Hence, the median, rather than the mean, is a more appropriate measure of central tendency. An extremely skewed distribution can also affect other statistics, and we'll be talking about that more throughout our course, but this concludes section 3-1.